I'm Mrityunjay Prasad, and this video is regarding solving multiple integral functions. Now herein we are given with this equation, but as it can be easily seen that it is not the easiest of the job to integrate this with respect to x. So we have to change it a bit. So for that, first we would be needing to draw the graph of this, which would somewhat look like this. So since we have to integrate it with respect to x first, so we have the limits from root y to 1, and the limits of y would be from 0 to 1. So we just have to write the same thing down here. So it would be root y less than equal to x less than equal to 1, rho less than equal to y less than equal to 1. But in order to do opposite of this, where we first integrate it with respect to y and then with respect to x, we need to change the limits. So for that, let's see another graph, which is basically same because the equation is same, but just here we would integrate it with respect to y, which means it would go from 0 to x square, and x goes from 0 to 1. So we would again write the same thing down here. X 0 is less than equal to x is less than equal to 1, and y is less than for y 0 is less than equal to y less than equal to x square. Now just rewrite the above equation, which is now integral of 0 to 1. Then from here we get the new limits, which is 0 to x square, and the rest remains the same, that is x cube plus 1 dy first and then dx. So now simply x cube under root x cube plus 1 would be treated as constant when we integrate it with respect to y. We will be left with integral 0 to 1 y x cube plus 1, and then we have limits and dx. Now applying the limits, upper limit minus lower limit, we will be left with integral 0 to 1 x square x under root x cube plus 1 dx. Since now we have this as the final integration we have to do, and now it can be easily seen that it is fairly easy. We just have to use the substitution method here, wherein we will let x cube plus 1 as t square, and then we would be differentiating both sides. Simple formula, nx raised to the power n minus 1, which would be 3x square dx equal to 2t dt, and from here we get x square dx as 2 by 3 t dt. Now here we have x square dx, here we have x cube plus 1, which can be substituted by this, and then we have x square dx, which can be substituted by this. But one more thing, we have to also take into account the very dear limits. So now to ensure what the limits are, it's simple. We have to put the lower limit first, which is 0. 0 plus 1 is 1, and then t square. So the lower limit will be 1, and the upper limit would be, the upper limit is t. The upper limit is 1 cube plus 1, which is basically 2, and now therefore t is equal to root 2. So we have upper limit as root 2 and lower limit as 1. This can be, again, as I said, easily be substituted. First you substitute the lower limit, which is 0. 0 plus 1 is equal to t square. That means t is equal to under root 1, which is again 1, and then we have upper limit as 1. So 1 cube plus 1, which is 2. Therefore t is equal to under root of 2. And we reach to our almost final destination, almost, not yet. 1 root 2. Then we have 2 by 3 t dt into t, which is equal to 2 by 3 t square dt, which is equal to into t cube by 3 1 to root 2. 2 by 3 upper limit minus lower limit again, which is equal to 2 root 2 by 3 minus 1 by 3. Wherein now we are left with simply we have to calculate all this value. This will simply be 2 by 9 2 root 2 minus 1. And we can leave this here, or we can further calculate the value of 2 root 2 minus 1, which would be approximately 2 by 9 into 2 into 1.414 minus 1. But if we calculate this correctly, we will be left with 0.4063. And therefore we have this question solved.